이번 발표는 ChainSafe 시스템의 Aidan Hyman CEO님께서 크로스-체인 콜라보레이션이라는 주제로 발표해 주시겠습니다. 큰 박수 부탁드리겠습니다.
Hey everyone, how's it going? Holy shit, it's bright. So yeah, thank you for having me. Wow, this is way brighter. I see why everyone was having trouble. Hi, how's it going? My name is Aidan Hyman. I'm a co-founder and CEO of ChainSafe Systems, and we're a group of 26 developers, researchers, protocol engineers who are, our mission is to build the infrastructure for Web3. So I'm just going to, talk a little bit about the work that we do, and just through the work that we've done as well, try and get across to you why, it is so important for us to work together as different protocols, different blockchains, and to create, these more standardized approaches to development and to how we kind of allow for new developers to be onboarded to the space, because our mission is to build infrastructure for people, not subject matter experts. And right now, if you're not a subject matter expert, you're really not able to do anything in the blockchain space. And that really has to change. So just a little bit about us. I'm going to go over 4 projects in the order in which we started working on them. So neither of them are more important. They're all equally important to us. So just to start with Lodestar. So Lodestar is an implementation of the beacon chain and really just the in-browser ecosystem for ETH 2.0. So what that looks like is a bunch of different tools, libraries, and things to support developers being able to build, dApps in the new kind of paradigm that is ETH 2.0. So we'll be working on a light client. We have our beacon chain basically complete. We have libraries like Simple Serialize, JS, BLS.js, and Gossip Sub.js that we've worked on to allow for a JavaScript, which now we've migrated to TypeScript in-browser experience for ETH 2.0. Gossamer. Gossamer is a Golang implementation of the Polkadot runtime environment. So this is a piece of software that allows for developers to build parachains within the Polkadot ecosystem and outside of it as well. It's just this piece of software that you could use to do really whatever it is you want to do. And you'll hear from my use cases or of projects that we've worked on in the past why it is so important to build modular frameworks for building blockchains as opposed to utilizing things that were made for generalized purposes like Ethereum, which is what we've done mostly for the past 2.5 years. Go Ethereum. So we've been maintaining the Go Ethereum client for Ethereum Classic, and we've upgraded the client to be ready for the new hard forks that are happening within the Ethereum Classic world. These are called Atlantis and Agartha, and we're really proud of this work because it's really helped us, get involved in Ethereum, another Ethereum chain, but one that will continue to be proof of work and allow us to work both on the ETH 2.0 side of things as well as what will continue to be a proof of work chain. And then Ethermint. This is the newest project that we've started working on that my colleague Austin leads, and it's an awesome project that is basically Ethereum on Tendermint using the Cosmos SDK. So this will be a Cosmos zone that allows for the hard spooning of state from Ethereum into Cosmos. And so how did we get here? Why are we doing this? What's the point of it all? So just over about a year and a half ago, 2 years now almost, since I made this slide, we started working on a sidechain. And so what is a sidechain? So sidechains are usually a fork of Ethereum, and they're usually optimized for a specific use case. So actually, traditionally, going backwards before Ethereum even, sidechains were usually chains that relied on merge mining and a whole bunch of stuff. But with Ethereum, it becomes a little bit simpler. These sidechains, they rely on interoperability because if there's just this siloed blockchain that has this application-specific use case, how do you take that and bring that to the rest of the world? And so the way we do that is with a piece of software called a bridge. And so what is a bridge? A bridge really simply is this piece of software that sits in the cloud or wherever you want it to be, and it interacts with two contracts, or you can on each side, on one side chain, and then potentially another side chain, and then potentially the Ethereum mainnet or the Ethereum Classic mainnet. And what that allows for you to do is have arbitrary data being passed around between these blockchains. So we'll go into I'll go into a few of those projects that we've implemented this kind of this software for. So we'll start with a local community governed blockchain. So this is a project that was already adopted by close to 20% of our city. We're from Toronto. And this was a project that was a really grassroots bartering economy that has a huge amount of users for something kind of within the blockchain context. And so we had to do a few things to allow for that to make sense. Because, we're talking about 300,000 users. And so the requirements for this were unique consensus, interoperability, of course, and a high TPS. And so what is this unique consensus? Well, it kind of looked like permission proof of stake. There's no really better language for it. And really these stores, what they did was they staked to validate the network. So these were stores that accepted this currency. Over 100 of them accept it now within Canada. And the stores, through like a kind of meta transaction type thing, are paying for these transaction fees. So making the UX really simple for users. And this, consensus, the consensus itself of the network is really just about, these stores deciding, hey, this makes sense for us. We're going to validate this network. So it's not really necessarily traditional mining or staking incentives. And so interoperability. So it was really important to allow for this token to be transferred and then used within a more generalized platform like Ethereum. So that's exactly what we did. And so we created a piece of software that took this ERC-223, which is basically an ERC-20 with a fallback function, and allowed for that to be brought over to Ethereum, where you can do whatever you want with it. Interact with DEXs, interact with other smart contracts that you're building or others have built, really do whatever it is you want to do. And a high TPS. So because we're talking about more trusted ecosystems, this allowed for a much higher TPS because we didn't have to worry about miners colluding against each other and things like that. And so what did we actually have to do to make this happen? We had to fork Geth. We originally implemented the parity bridge, which was written in Rust, which we then realized that we should probably be writing this stuff in a language that makes sense for more developers than just kind of us. So we re-implemented, or didn't really re-implement it, built our own in Go, which for us has been a much more usable language for developers that kind of interact with our software, and for clients that want to work with us. And we implemented this unique POS. So what were the lessons learned from this project? All right, what did we take away from this? Firstly, we need more modular consensus within Ethereum clients or within blockchain clients in general. So at the time, really all you could do is fork Ethereum and do what you needed to do for it to make that happen. So, we kind of came to this conclusion that, hey, this is a generalized smart contracting platform. It was never meant for these things. Why are we forcing this? And then also hybrid models are necessary for scale. At the time, this is a year and a half ago, scalability research was nowhere near where it is now. And so, the need to maybe have some kind of more permission system was really necessary. So this wasn't permissioned in a traditional consortium sense, but it still had, levels of permission to it. And then also local blockchains can be successful. Who knew? A small project from Toronto could end up having 20% of our city using a project that interacts with some kind of cryptocurrency, right? This is 100 stores in Canada, and it's a project that probably none of you have ever heard of. And it has more traction than a lot of projects in the world right now. So that's also something that we don't really necessarily think of when we think of, this global computer. Yeah. So example number 2. And so this was an interoperable attestation network. So what does that mean? That means that this was a network that required for proofs to be created of a certain, I won't go into too much detail, but they were creating proofs of some kind of piece of information that could then be interoperated from these kind of centralized services to different blockchain networks. And so what were the requirements for this? Well, we needed proof of attestation through opcodes. We really needed, at the lowest level, to be able to do these proofs. And so that literally meant implementing opcodes into the EVM and adding functionality to the EVM. And this is not an easy feat. And not only is it not an easy feat, it's not something that's recommended for most people to do, and way beyond the capabilities of what a normal developer will ever be able to do. But this was extremely necessary to be able to accomplish what we needed to do at the lowest level in the most secure way possible. And this needed a unique consensus mechanism. We're talking about, the ability for these different providers to then interact with these decentralized networks. And so, we needed to ensure that 51% attacks were really, basically a lot of things needed to be implemented to ensure that this network would be secure. So, safety over liveness was definitely a main thing that we were kind of tasked with accomplishing. And interoperability with multiple networks. At the end of the day, they wanted to interact with EOS, they wanted to interact with Ethereum Classic, Ethereum, and even more projects as well eventually. And so what does a proof of attestation work? As I mentioned, this literally meant adding opcodes to Geth. So these are adding instructions to this Ethereum virtual machine thing that we always talk about. And that meant also then having to interact with the compiler, the Solidity compiler, and to add the functionality of the opcodes that we implemented. And that also meant looking at Solidity and adding this functionality to Solidity, the DSL that we use to write smart contracts in Ethereum. And it also meant looking at the Ethereum IDE remix and doing the same thing. And after all of this work, it was clear that, at the beginning, our intention was that, we would learn a lot, we would be able to optimize certain things. For example, this project wanted us to ship a block explorer with the client. So, this was a Geth client that would ship with a block explorer with a Postgres database in a way that would allow anyone to kind of, run a block explorer directly on their node. So there was a few things that we intended to eventually allow for an upstream kind of merge. So, bringing this back to the wider open source community. Now, unfortunately, none of that could happen based on what we had to do to actually implement these things. These were basically breaking changes. So what did this unique consensus mechanism look like? So we were looking at auth hash, which is basically, some kind of, permissioned proof of work type thing. And at the end, proof of work was chosen, mainly from a pragmatic perspective of Geth was never meant to have a consensus mechanism change. And the interesting thing here was that we basically implemented it. We basically did all the work, and at the end of the day, there were so many issues with maintaining upstream compatibility that it was actually decided to just throw out all that work because of the inability to allow for that to kind of be maintained in the future when we left the project. And then interoperability with multiple networks. It was extremely important that we would have interoperability with multiple networks. When we're talking about sidechains, that is where all the functionality really gets to be utilized, is when we kind of bring these things further outside of the siloed blockchain. And so what did we have to do to make this happen? So again, we fork Geth. We implement a bridge that passes its attestation data. So the way that it worked was extremely different than a lot of the bridges we hear about usually. There was even consensus amongst the bridge operators, just a bunch of really exciting things that are unfortunately not really seen a lot. And then we had to obviously implement this consensus mechanism into Geth that eventually just was discarded after all of that work. And so what did we learn from this? So we learned that we need more modular blockchain components. We need an ability to take software, open source software, and interact with it, add to it, extend it, but then also allow for it to be maintained in an easy way, in a way that's compatible with upstream kind of changes that eventually will be made. Again, hybrid models are possible, and not only that, are really advantageous for smaller projects looking to bootstrap a network. And a really important point, if there's anything you take away from this, is that after almost a year and a half of work that we worked on this, everything open source you can see on GitHub, the only upstream PR was for one of the components that we worked on, which was Remix, in which we just added Control-S to not save the IDE in browser, but to instead recompile. So a really minor change, very much just on the UX side of things, and not really not really what the intention was, which was to allow for a lot of these components to then be reused and merged upstream. And again, interoperability is only as useful as it is usable. If we're not able to, build these things in a way that allows or empowers developers to try these new blockchains, to attempt to interact with these new technologies, even with layer 2 kind of scaling solutions, in a way that doesn't force them to be subject matter experts, we're never going to reach scale. We're never going to reach mass adoption, because it starts with developers. And if developers cannot take a chance on becoming a subject matter expert in one particular thing, they'll never, be able to actually kind of contribute to this space in a way that allows for their dreams to be realized. And that never scales. That is never going to kind of lead to what we want, the people in this room, we want to see this technology being used in the day-to-day world. And that can only be done if we build things for developers first, for people, not subject matter experts. So that's basically it for me. That's my contact info. It's pretty small up there. That's our company Twitter. If you want to see all the shenanigans that we're up to, at ChainSafe. If you want to send me an email, my name is Aidan, and it's at chainsafe.io. Our website is chainsafe.io. And the GitHub, we've actually changed that. We had our slice day, and it is now just github.com/chainsafe. So if you want to check out what we're doing, please just go to GitHub. I'm not here to sell you on anything. I'm here to tell you, let's work together to build things that make sense for developers. Because if we just sit in our siloed kind of rooms and our siloed offices and we don't work together, no one's ever going to use any of this stuff. And that's a real shame. All of this work, all the billions of dollars raised just to make people, happy in the speculative market. The reason we're all here, the reason those billions of dollars were raised, were to build things, to build the future of technology. And so together, and only together, we can make that happen. Thank you. So yeah, if you have any questions, it would be great to hear them. But if not, I'm going to be here afterwards. My colleague Austin's here. Yeah, let's talk, let's chat. Korea is awesome. It's been great to be here.
혹시 질문 있으신 분들 손 들어주시기 바랍니다.
Thank you very much. Have a good day, everyone. Thank you.